The paper of the day is the Gamma Database Machine project. This paper describes the design of the Gamma database machine and the techniques employed in its implementation. Gamma is a relational database machine currently operating on an Intel IPCS2 hypercube with 32 processors and 32 disk drives. Gamma employs three key technical ideas which enable the architecture to be scaled up to hundreds of processors. First, all relations are horizontally partitioned across multiple disk drives, enabling relations to be scanned in parallel. Second, novel parallel algorithms based on hashing are used to implement the complex relational operators such as join and aggregate functions. Third, data flow scheduling techniques are used to coordinate multi-operator queries. By using these techniques, it is possible to control the execution of a very complex queries with minimal coordination, a necessity for the configuration involving a very large number of processors. The Gamma project uses a shared nothing architecture to build a horizontally scalable database for the same reasons we see NoSQL vendors tackling the same problem today. Communication between nodes in the system is handled exclusively by passing messages between one another over the network. Gamma is divided into several processes. The catalog manager handles the database schema and metadata information. The query manager is associated with each Gamma users and is responsible for providing ad hoc query support. Coordination of multi-node queries is handled through scheduler process that handles the execution of individual operator processes on each node. Gamma maintains a split table mapping tuples to the node that the tuple resides on. Queries are then shipped to the node where the tuple resides for processing. Selection operators are parallelized over all nodes by initiating a selection on the set of nodes where the required tuples are held. If the selection query is based on the attribute responsible for building the split table, then a subset of nodes will be engaged to process the query. Otherwise, the selection operator is run on every node in the cluster. Join operators are executed using the hybrid hash join algorithm, where relations are first partitioned into n buckets, and the first bucket is used to build an in-memory hash table. The remaining buckets are stored in the temporary files. The join operation is run on the in-memory hash tables, and once complete, the remaining buckets are loaded into memory and joined on. In this way, a large join is broken up into a series of smaller joins. Aggregate operators are executed by each node in the cluster, and the results combined into a final answer at a single node. To evaluate the performance of the hypercube version of Gamma, three different metrics were used. First, the set of Wisconsin benchmark queries were run on a 30-processor configuration using the three different sizes of relations, 100,000, 1 million, and 10 million tuples. The benchmark relations used for experiments were based on the standard Wisconsin benchmark relations. Each relation consists of tuples that are 208 bytes wide. Gamma uses two key ideas for enabling a scalable architecture. First, relations are partitioned across nodes in the cluster, allowing for parallel data scans without any specialized hardware. Second, Gamma popularized hash-based parallel algorithms for join and aggregate operators.